Hey everybody, welcome to today's video. We're still looking at polynomials. This is actually going to be the first lesson that I have never taught to my students. This would have been lesson 7.4, which we never got to. So anyway, this will be brand new material. Because of that, I'm going to take a little bit slow. Today we're just going to do the first half of lesson 7.4, and then tomorrow I'll post a video for the second half of lesson 7.4. So this is brand new stuff. I hope it still gets across and people understand it. But nonetheless, what we're looking at today is polynomials when they are equations, right? So far we've been adding polynomials, we've subtracted them, we've multiplied them, we've classified them according to their degree, we've put them in standard form. You'll notice the title of today's lesson, Solving Polynomial Equations. That means they're all going to have an equal sign and they're all going to equal a certain number. Today it's always going to be 0. And then the thing today is these are always going to be in factored form, right? You're not going to see anything like this, where this is a polynomial and it is an equation, but this is not in factored form. That's what we call standard form. Remember, you go from highest degree down to lowest degree, second power, first power, 0 power, or second degree, first degree, 0 degree. So we'll save these for another day. Today, they're always going to be in factored form. Factored form means it's always going to be a multiplying scenario, right? It's usually going to be 2, it could be 3 or more, but usually 2 factors that are being multiplied together. Like these are actually multiplied. You're never going to see someone actually write a dot in there, but that is always just assumed. That is part of the question. So the big idea today is whenever it is in factored form, and today it's always going to equal 0, it makes the question super easy. Because what do we know about 0 and multiplying? There's this big rule in all of math, not just algebra, but this giant rule called the zero product property, right? And usually when I first introduce it to students, I just say, all right, guys, if we're doing a multiplying question and we know the final answer is 0, what can you tell me about these question marks, right? What type of number should be behind these question marks? And most kids, even the kids who maybe struggle a little bit with math, if you've paid attention at all in elementary school, you know that the only way to get a final answer of 0 in a multiplying equation is to have at least one of the numbers be 0, right? One of the factors, one of the things you're multiplying has to be a 0, right? For example, this could have been 0 times 5, or it could have been 0 times 6, or 0 times anything, right? But did necessarily the first question mark, did the first number have to be 0? No, not really. Could it have been the second number that was the 0, right? Could we have had something like 7 times 0? Yeah, we could have had that, right? As long as 0 is in there somewhere, we know that 0 has to be at least one of the question marks. Could 0 have been both the question marks, right? Could this have been 0 times 0? I guess that's possible too, right? And so the big idea behind the zero product property is that if you have a multiplying question and you know the final answer is 0, you know that one of the factors or both of the factors had to equal 0, because the only way we can get 0 as an answer to a multiplying question is to have one of the numbers that we're multiplying with be 0. Because we all learned in elementary school that 0 times anything equals 0. It's what made the 0 times tables the easiest ones to do, right? Remember when you're in second grade, third grade, fourth grade, and you had to do all those multiplying tables? The 0 one was always the easiest because the answer was always 0. And that's the big idea today. Okay, so moving on to what an actual Algebra 1 question will look like. They'll give you a statement like this, and they'll ask you, okay, solve this for x. It's the same idea as up here, right? Instead of question marks, I just have replaced the question marks with a parentheses. We have a final answer of 0. So what does that mean? That means that either this parentheses or this parentheses had to equal 0 because our final answer is 0, right? So basically what you're asking yourself is, what value would x have to be to make each one of these parentheses equal 0, right? What number would I substitute right here for the x to make this entire parentheses equal 0? And most people can say, okay, yeah, 5, right? 5 minus 5 would equal 0. So if x equaled 5, we would have a statement where the first parentheses would have been 5 minus 5. The second parentheses would have been 5 minus 2. To be honest, the second parentheses doesn't really matter very much because you'll end up with 0 times 3, and 0 times 3 equals 0, right? So if the first parentheses had x equals 5, we would get a final answer of 0. But what about the second parentheses, right? What number would I substitute in for the x right here to make the second parentheses equal to 0? So you're asking yourself, okay, what number minus 2 would give me 0? And that's obviously 2, right? 2 minus 2 would give us 0. If I plugged 2 into this original problem, right, if I put 2 right here, I would have 2 minus 5, which is negative 3. And so I would have negative 3 times here, 2 minus 2 equals 0. So we'd have negative 3 times 0, which also equals 0, right? And so that's the main idea. This is almost like a mental math question once you get the hang of it, right? You really don't have to show all that work. Most students will pick up on these pretty quickly, and they'll just be able to look here and say, okay, in this parentheses, what number would I plug in to make it equal 0? 5. In this parentheses, what number would I plug in to make it equal 0? 2. And there you go. You have 2 answers on these questions. If there's 2 parentheses, you should have 2 answers, unless the parentheses are identical. So in this question, x could equal 5 or x could equal 2. They're both correct answers. Right? Sometimes when they're looking to get a little bit tricky on you, they'll do this, where they'll just do 1 parentheses and they'll put squared on it. Don't let that bother you, right? That's the exact same thing as this. And so if you solve it like this, or with the red equation, it's the same answer. You're going to ask yourself, okay, how did they get a final answer of 0? One of the parentheses, or in this case both of the parentheses, since they're identical, had to equal 0. So what number would I plug in right here to make the parentheses equal 0? That has to be negative 1, right? If x equaled negative 1, we would have negative 1 plus 1, which would equal 0, and 0 squared equals 0, right? Or right here, if you put negative 1 in this parentheses, and if you put negative 1 in this parentheses, both of them are going to equal 0, and you would have 0 times 0. And so in both cases, your answer is going to be x equals negative 1. Now, because there were 2 parentheses, or because it was squared, do I have to write negative 1 twice? No, you can just say x equals negative 1. What they call this is a, I don't know if you'll actually need to know this definition or this vocabulary term. They call this a repeated root, just because your answer repeated itself, right? We had negative 1 as our answer in both parentheses. When you actually find these answers, they're actually called roots. Right? Sorry, that's not really on my camera. Let me scroll back a little bit. They're called roots. A little bit later on in the class, we'll learn that roots are the same thing as the x-intercepts. Whenever we go to graph these, these will be the places where the graph touches the x-axis. And so that's something for a later date. I don't want to get into that right now. But anyway, that's the main idea for today's questions. Let me show you a couple more examples. Hopefully we can pick up the familiarity with this. Okay, on my next board here, I gave 4 examples. Most of them are similar to the ones we did before. Right? In my number 1 example, you have y minus 6 times y plus 2 equals 0. So if you can do this in your head, you know the final answer is 0. You know this is a multiplying question, and so you can just focus on each parentheses one at a time, right? In this parentheses right there, what number would I substitute in for the y to make the whole parentheses equal 0? And most people are going to say, well, if you had 6 there, right? 6 minus 6 equals 0. And so one of our answers is y equals 6. And the other parentheses, I'm just going to highlight it right there. What number would you have to substitute in for the y to make this entire parentheses equal 0? And I know that's kind of in the glare. It says y plus 2. So if I had negative 2 in the spot of the y, that would be negative 2 plus 2, and that would equal 0. So if y equaled negative 2, we would have a 0 times something equaling 0 situation going on. Okay, on number 2, I tried to make it a little bit tricky by giving you 3 parentheses. Should that really change the way we do these? No, it's the same idea, right? It's the same concept. In the first parentheses, what number would you plug in right here to make it equal 0? That looks like 4, right? 4 minus 4 would equal 0. So one of the answers is 4. But we have 3 answers on this question, don't we? In the second parentheses, I'm dropping my markers. Second parentheses, what number would go in for the spot right here to make the whole thing equal 0? How about negative 1, right? Negative 1 plus 1 equals 0. And in the final parentheses, I went with the double-digit number. Don't let that change your idea, though, of what you're doing. What number would you substitute in there to make the whole thing equal 0? That parentheses would equal 0 if we had negative 12, right? Negative 12 plus 12 would equal 0. And so we have three answers on this one, positive 4, negative 1, and negative 12. So you can have more than two answers. You can have three, you can have four. It just kind of depends how fancy whoever writes the question wants to make it look. Okay, when they try to get a little bit cute, they might do something like 3 and 4. You're like, uh-oh, wait a second, it's not in parentheses anymore. That's okay, don't let it bother you. In fact, if you want to put it in parentheses, you can. It's the same idea, right? There's no adding or subtracting going on, but it's the same idea, right? So if you want to focus here at the beginning, you're going to treat it almost like it is a parentheses, right? What number would I have to substitute in for the x to make this entire parentheses equal 0, right? Basically, you're asking yourself, 2 times what would give me 0? And the answer to that is 0, right? If this was 2 times 0, we would have 0 as our answer. So x could equal 0. In the normal parentheses, you're going to do the same thing we have been doing. What number would we put right here for the x to make this parentheses equal 0? What number plus 6 would leave us with 0? That's got to be negative 6. So x could equal 0, and x could equal negative 6. Okay, we have one more. Number 4 is at the bottom. Do this one with the purple. The second answer is obviously the easiest one. Most people are going to know this one right off the bat. What if it's just a plain old w or a plain old x or plain old y out here by itself? Does that still count? Do I still have to do that? Yeah, you do. If you want to put it in parentheses just like the other one, okay, you're just going to ask yourself, what number would I plug in for the w to make it equal 0? And you're like, okay, there's no adding, there's no subtracting, there's no multiplying, there's nothing going on out here. So is it just 0? Yeah, it's just 0. If they just have a plain old letter out here with nothing else, it's just going to be 0. And then in this one, it's obviously got to be 18 because 18 minus 18 would equal 0. And so 18 is the other answer. All right. Hopefully this isn't too hard. This doesn't take too much to get the hang of. It just kind of takes some practice because they are kind of weird. Let me show you when they decide to get tricky and they decide to ramp it up just a little bit on the difficulty, not too much. But about the hardest question we're going to look at today is going to look like this, right? What's going to happen when it's not just x plus something or x minus something or w plus something or w minus something? What if they have some coefficients, right, in front of these x's? All of a sudden my x's, my w's, my whatevers, they're not just plain old x's. They've got 2's and 3's and 5's and stuff in front of them. This makes it a little bit more complicated, but it's the same idea. I'm not going to stress out. I'm not going to panic. If I'm looking at this first equation, I'm focusing on this parentheses. I don't know how many 8th graders I have who could do this in their head. If I said, hey, what number would you substitute in for a w to make this parentheses equal 0? That's pretty tough for an 8th grader. Some of them could get it, but not a lot of them. So if you need to take this and off to the side, write it out like this and say, okay, I want to figure out how I could make this parentheses, this is what was in the parentheses, right? I just copied it down, equal 0. What number would I substitute in for w to make it equal 0? And from here, this should be like a two-step equation. You've done this all throughout 6th grade, 7th grade, 8th grade, whenever you learn this first, right? If I want to solve this for w, what do I need to do? Well, I'm going to do the inverse of adding, which is subtracting, right? Whatever you do on one side, you do the same thing on the other. You'll end up with negative 3. You'll end up with 2 times something equals negative 3. And then now the w is being multiplied by 2. So how do I undo multiplying by 2? I divide by 2. And I get the answer off to the side right here. W equals negative 3 over 2. If you're like me, you kind of prefer decimals. If you want to call that negative 1.5, I'm cool with that. So if you need to work the question out, draw it off to the side, make it equal 0, and then just work it out like a two-step equation. Okay, that's one of our answers. Actually, I shouldn't have put a box around that. I'm going to put negative 1.5 just because I prefer decimals. That was the first parentheses, but hold up. Don't get too excited. You're pretty happy here with yourself because you're like, oh man, I got the answer. I'm done. Whoa, you've got a whole nother answer. What is going to make this parentheses equal 0? Now, this one's easier because it's just w plus 5. I guess if you really wanted to, write it off to the side like we did the other one. How could I make this equal 0? Well, I could just do minus 5 on both sides. I guess this is the way I would have a student do it who is really, really struggling. But to be honest, most students are not going to need to do that. Most students are just going to be able to look at this and say, okay, if you put negative 5 right there, it would be negative 5 plus positive 5, and that would equal 0. And so we have two answers on this one, negative 1.5 or negative 5. Okay? So that's about as hard as they will make it, right? Let's do another one like that just so we get a little more familiarity with it. This one I have squared. That just means we're going to have the same answer 2 times. We're going to have another one of those repeated roots, but don't let it bother you. What number would I plug in right here for the w to make this parentheses equal 0? Oh, that's kind of hard to do in my head, especially when I'm first learning it. So if I need to write it out, take the parentheses and just write what's inside the parentheses. Notice I don't have a parentheses around it anymore. Make it equal 0, just like this question equals 0, and then just work it out. This should be a 2-step equation. Most students in 8th grade should be able to do a 2-step equation. Just ask yourself what's happening to the w. It's being multiplied and it's being subtracted, right? I've got to undo the subtracting with adding. Whatever you do on one side, you do the same thing on the other. I'm running out of room. 3 times something equals 4. Ooh, that's not mental math, is it? So the opposite of multiplying by 3 is dividing by 3. And I apologize because I'm out of space, but you can see it right here, 4 over 3. Whoops, I just put a cross through there. 4 over 3, which is the same thing as 4/3 or 1 1/3. Right? One of my answers would be w equals 4/3, or you could put 1 1/3. And you know what? That's actually both answers because this thing is squared. So I don't have to write it twice. I can just write it one time. That's another one of the repeated roots. Okay, and then our grand finale, if they gave us 3 parentheses, I guess I technically don't have 3 parentheses here. I have 2 parentheses and then just a 2x at the beginning. Usually this stuff at the beginning just equals 0, but just to make sure, if you want it to look like a parentheses, like the others, you can just put it in parentheses. There's nothing wrong with that. That's not going to hurt anything. We're going to do this just like we have been, right? What number would I put right here to make it equal 0? That would have to be 0, right? 2 times 0 would equal 0. And so one of my answers is x equals 0. That's going to be my first one. My second answer, what number would I put right here to make this parentheses equal 0? Let's see. I'm going to put this in green. If I don't know this in my head, I'm going to go off to the side. I'm going to go way over here. I'm going to do 3x plus 2. That's what that parentheses had inside of it. I'm going to ask myself, okay, I'm wanting it to equal 0. I want to figure out what number would x equal to make this whole statement have an answer of 0. I'm going to do inverse operations. Instead of adding 2, I'm going to do subtracting 2. Instead of multiplying by 3, I'm off the screen. Hang on. Instead of multiplying by 3, I'm going to divide by 3. And I'm going to get this, x equals negative 2/3. That's my second answer. I'm going to put it right here underneath my first answer just to kind of keep it organized. And now I'm down to the last one. I've got one more little 2-step problem to work out. I'll put this one in red right here. 5x minus 1 equals 0. What number would the x equal to give me an answer of 0 for this parentheses? Oh boy, I don't have a lot of room. I'm just going to do it right here. I want to figure out what's going to make that statement equal 0. And now it's a 2-step equation again, right? Instead of subtracting 1, I'm going to do adding 1 on both sides. That's going to give me 1. I'm going to have 5 times something equals 1. I don't know that in my head. I don't have space, but I'm going to divide by 5 on this side. It's going to cancel out. I'm going to divide by 5 on that side, and you're going to get x equals 1/5. That is your other answer. And obviously, if you love decimals, you could call that 0.2. You could call this negative 0.6 with a repeating bar if you're a person who just absolutely loves decimals. And there you go. That is how you would do probably the most complicated question they would give you in our Algebra 1 textbook for today. So, if you are a person in my Algebra 1 class, I'm going to try to post a group of questions on our Big Ideas Math class website. And you can give it a try if you feel like you want to test your skills. If you're a person who's not in my math class and you're wanting a chance for your student or maybe yourself or just wanting to practice, this is a website. Sorry, I had to extend it out into like 3 different lines here. When I stack these boards on top of each other, they lose a little bit of the marker, gets wiped off whenever I stack them up. But this is a website that I think will let you practice like 10 questions online. ixl.com/math/algebra. These are all hyphens, right? Or dashes, -1, \solve -a quadratic -equation -using the -0 product -property, right? This website, hopefully you can type it in there with all those dashes and it should work. It'll let you give yourself 10 practice questions. I think you get 10 free each day, and then you have to buy a membership. So once again, If you're a student in my class, go to the Big Ideas Math website. I'll post an assignment here in just a little bit. You can do if you want, and if you don't want to, that's fine too. And if you're just online or just somewhere out there, not one of my students, you can go to this site and practice 10 of these questions for free as your daily chance to practice some math. So thank you so much for watching, and I will catch you guys in the next one.